Please welcome our next speaker, Mr. Sam Williams. He is co-founder and CEO of Arweave. The topic of this keynote speech is permanent decentralized storage as building block of Web3. Welcome.
Thank you for joining me today. I'm sorry that we can't all meet in person, but I'm excited to tell you about Arweave, which is the permanent decentralized web. So, put in simple terms, Arweave is a blockchain redesigned to store massive amounts of data inside. You can think of it like on-chain storage that scales. So, in the first block of Bitcoin, Satoshi included this reference to a headline from the Times in the UK, talking about the second bailout of the banks that was on the cards at the time. Well, we've essentially scaled that idea that you can store history inside a blockchain and made it so that you can fit arbitrary amounts of data inside, not just very small memos. The idea here is to build a digital library of Alexandria that is impervious to fire, flood, and other forms of damage. The essence of what we're creating is essentially a kind of collective memory, is the idea. So everyone can write to this place in the permissionless style that we see in other kind of blockchain systems, except in Arweave we're focused on data. So anyone can permissionlessly add to this archive and make sure the data that they think is important is replicated for all of humanity to see for all time. We've been using this in practice for nearly 4 years at this point, and our community has grown pretty vibrant and has started to store artifacts from all sorts of historical events, including most recently nearly 70 million documents now from the Ukraine-Russia ongoing crisis. So how do you actually make this work? Well, you need to solve two fundamental problems. The first is permanent storage sustainability, and the second is technical, which is scalability of the data. So we're going to start with the second. So scalability, how do we do this? Well, the first thing we do is we replace the proof of work mechanism found in Bitcoin with a mining system we call succinct proofs of random access. Broadly, it works like this. When you are trying to generate a candidate block, or rather trying to get a block accepted by the network, you generate a candidate block, just like in a normal blockchain system. You guess a nonce, again, just like a normal blockchain. And then you hash those two together, similar to a normal blockchain, but with the output of that hash, you interpret it as a number, and then you modulo this against the size of the network. So that's essentially saying, take this number and put it in the range of the number of bytes that have been stored in the network. And that becomes what we call the recall byte. And in order to continue with the mining process, you have to prove that you can access that byte. So you recall it from disk, you make a Merkle proof of its location inside the network, so you can find the chunk that it's within and then find the Merkle path, essentially, that takes you from the that chunk of data to the transaction that it's inside of, and then from that transaction to the block, and then that block to the whole network. And then you hash all of this again, and then you check the results against difficulty. And what this is essentially doing is incentivizing miners to expend as much value as possible on the storage of data rather than the wasting of energy, essentially. And so the more of these recall bytes that you store, the higher the likelihood that when it is called upon, when you get to this stage 4, you can recall the data and move on to the rest of the mining process. And because stage 4 makes up the vast majority of the time spent in the mining process, that actually moves more of the value expenditure away from energy and towards the storage of data. This essentially makes a system that kind of wraps previous transactions from other blocks into the creation of new blocks. Kind of we used to call this process a block weave, although that I think maybe just complicates things. But basically you're weaving together the blockchain rather than adding a block on top of the last one. You're kind of looping it in with the one prior part of the network. So, okay, now you've made it so that you can store arbitrary amounts of data on chain. This sort of highlights an issue that was already present with blockchain designs in general, which is that they are ever-growing ledgers without incentives to store the old part of the ledger. Well, we came up with this endowment approach to solving this problem. So essentially, when you put a piece of data into Arweave, you pay for 200 years worth of the storage of that data at the present price, at the day you put the transaction into the network. Then, as the cost of storage declines over time, that 200 years of storage expends out. And so as long as the rate of storage cost decline stays above 0.5%, then at the end of any given year, you end up with more storage purchasing power for the money you already put aside than you started with. And in typical times, so the last 50 years, the cost of storage decline has been around 30.5% on average. And so this is a fairly safe margin, and there's a very, very, very long amount of time to grow with this system, essentially. Like the distance from where we are now to the theoretical data density maximums, moving even at a rate of 30.5% per year, it would take us 434 years approximately to get to the maximum of that system. So it's an extremely long-term storage network. So what is the Permaweb? Well, the Permaweb is all of the information found inside Arweave, accessible in people's web browsers. The idea is to sort of fulfill the mission of the original web, which was to become this enormous knowledge base available to all people across all time, but add now memory, which was missing from the original protocols. So this is why Arweave is useful for storing knowledge, but why would you want to build applications on top of the system? Well, we like to think of this as knowledge essentially being analogous to applications in computers. That is, a piece of knowledge is a way of thinking about the world and a way of acting in the world in order to achieve a task. You can think of it like a set of instructions. Well, for computers, apps are essentially the same thing. They are instructions about how to achieve something. And so, on top of this system, it was very natural that you can essentially store knowledge for computers and have them animated and then look like applications to users. So one of the reasons you might want to build on top of this system is that permanent information storage, while it sounds sort of simple, it actually has quite a few fairly complex implications. And one of those is that it changes the relationship between humans and information. So once a piece of information is stored in the network, nobody has privileged control over it, not even the person that stored the data in the first place. And this means you can build web applications that are outside the control of any individual or party. Or you can build applications that are controlled directly by their users. And you can think of this as, code is law in Ethereum. Well, in Arweave, Permaweb applications, the code of the web application is the law of the web service. It's the same idea, but applied instead of to finance to web services. And so you can have a DAO, for example, operate a web application and vote on things like how the fees should be set for an application or what should be highlighted on the homepage that day. But the important part is that after the launch of the application, the developer can't change it, the users can't change it. The rules of engagement, if you like, of that web application are set in stone from the start. You can build applications on top of the system that users can trust far more than typical Web 2 apps. So in the Web 2 world, the application lifecycle goes like this. An application starts off free and it's increasing in quality. So a founder creates a great idea, they launch it and people like it, they start to use it, and they also find that they are sort of accruing additional costs as they get more users. So each additional user creates more fees that the developer has to pay. This is a problem, the developer has to find a way of paying it. So typically they go and they get venture capital funding. Venture capital funding means that they can bankroll the market capture phase of the application's growth. But at the same time, the founders are typically losing control of it and giving that control to VCs on the board of the company. Eventually, once the market has been fully captured and there is some kind of moat in place, which makes it hard for users to leave the application, the switch flips. And instead of being about offering the best possible quality service to users, it becomes about offering a good service, but also extracting as much profit from the users as you possibly can. And this is just the system in Web 2. So you get this sort of arc where the quality of an application starts to decline over time. Well, in Permaweb applications, that simply can't happen. So instead, what we have is a situation where if the developer wants to issue a new version of the application, they cannot force the old users to move to the new version. They can use the old version if they want. This leads to a different power dynamic between developers and users, where the developer is able to add, intrusive adverts or sell people's data if they want to, but they have to convince the users that that is an increase in the quality of the overall application. So perhaps they can bundle it with new features that the users want, and it's a sort of negotiation rather than users becoming locked into a platform that they cannot leave. It's just a fundamentally different way of structuring web applications. We think it's better. So here you can see weavemail.app. Weavemail was built by Lev on the Arweave team and I 3.5 years ago at this point. It's an application that never sells your data. So it's a sort of email on a blockchain, if you will. It doesn't sell your data. It doesn't have any intrusive adverts. And we can't control it. And it's been live for 3.5 years, and people still use it every day. And there's no chance that the quality of the service will decline in the future. When you compare this to Gmail, for example, you realize that maybe Gmail isn't the dominant service in Shanghai, but if a typical webmail service on the internet right now, your rights are not necessarily protected. You trust them with your identity. So you set up, your WeChat ID or whatever it happens to be, and WeChat essentially owns this, and they can do whatever they want with the service. And if you've given out this ID for other people to find you there, you can't really leave when they change the service to, for example, add intrusive adverts or start selling your access to your data to other people and so on. Well, with weavemail, what you see is what you get forever. You can build applications in the system with open data. So you can think of the Arweave network kind of like a data lake, in the same way that Ethereum is a composable ledger of programs that can all interact with each other. Well, Arweave is the same, but for data. So when you build an application on top of Arweave, you can use all of the other data that already exists in the network as if it was in your application itself. This is really powerful because it allows you to sidestep the there's a name for this. It's the false start or empty start problem. But essentially the idea is that when you start an application, particularly social applications, there's no content on your app to begin with. Well, if you build your application on top of this system, you can easily include the data in other apps in the ecosystem, and they can build on your data too, adding value to it. As we can see here, here's another weavemail client. So Lev and I built weavemail 3.5 years ago, but 2 years ago, someone from the community came along and they built this much nicer UI for it. And this is available on the Permaweb, and many, many people use this version of the UI as well. It uses the same data protocol underneath. It's essentially composing on the same protocol that we set up originally. And the developer of this application takes a tip, a fee, every time someone uses it, because they're willing to pay that fee because it's better than the original. And so that's that process of ever improving application quality in practice. Okay, on top of this system, you can also build applications with zero maintenance costs. This sounds pretty bizarre, but it's true. The way that this works is that we have separated the responsibility of providing infrastructure for a web service with the responsibility of providing code. So in a typical Web 2 world, you don't just let your users access the source code of something. You instead let them access a website, and that website is a deployment of the code on a set of infrastructure that you, the developer, operate. And subsequently, you, the developer, accrue all of the costs of operating that service. So in the case of Arweave, this is totally different. A developer pays to submit the transaction to the network, the upload of the source code, if you will. And in the case of Weavemail, that was about 1/100th of a cent 3 years ago. And then the user creates a financial relationship with a gateway of some sort that allows them to render that application and sort of animate it, if you will, into something that looks like a web service to the user. And the financial relationship there can be fairly arbitrary. So at the moment, people can use Arweave.net for free, but there are also people spinning up gateways that have premium services that are faster, for example, which you can pay for. Or maybe you see ads on these gateways, and so on. There are many different ways of operating this system. So how do you build these applications? Well, if you can build simple JavaScript web applications, you can build on the Permaweb. You simply build as normal, but instead of using user accounts, you just use RVJS to interact with the user's wallet. This pops a window like this that'll be familiar to you if you've used MetaMask before, and allows the user to sign transactions. At the moment, you can let your users use your applications if they're using small amounts of data for free, because Bundler Network will subsidize transactions under 100 kilobytes. So you just have any user come along and make a new wallet. They don't have to have any tokens inside it. That's just, you get them to store their identity rather than a username and password. And then they can use your application like straight away. And they don't need to go through any of the complex Web3 onboarding systems we've seen in the past. And if they want to store larger amounts of data, then Bundler also allows them to pay using tokens on Ethereum or Ethereum layer 2 systems like Polygon, Optimism, or Solana, Near, Avalanche, and many, many other networks. And so you can essentially pay using all of these other tokens, but in the back end, Bundler is settling the transactions to the Arweave network using its native AR token. But the user doesn't need to see that, and that's a really powerful way of opening up your applications, decentralized web services for everyone to use. So instead of using a back-end database, you simply use GraphQL. Many of you will be familiar with GraphQL, but if you're not, it makes queries look a little bit like this. So here we're saying, please give me every transaction that has a tag with a content type, text, stroke, HTML. So we're looking for web pages, and a user agent that's this automatic archiving bot. But you can easily change that for, please show me all of the posts from this user ID or this wallet ID between these, such and such a time and such and so on. And then you can simply combine these queries to make fairly arbitrary web applications, everything from decentralized GitHub replacements all the way to decentralized Twitter and Facebook systems. Finally, you just need to deploy this with ARKB or ARKB, which is just one line in the command line. But if you don't like using the command line, you can use a system called Argo, which is a GitHub integration where you can press one button and have your application deployed straight to the Permaweb and update your DNS records so that a human readable name now relates to a transaction hosted on the Permaweb. Finally, you've built your application using the system. How will you govern it? So I quickly showed you this before, but this is community.xyz. It's a simple DAO or DAO system for allowing you to, or users to control the applications that you've built. You can vote for things like here, this number 1 vote is setting the fee, but you can also vote for, here's the content policy that we're going to use in our application, and so on and so forth. And you can access these DAOs extremely simply, just including this JavaScript library into your web application, It's one line, and then you can say, hey, please get me, this parameter from this DAO. And so you can say, the highlighted post of the day is this, and you can encode that in the presentation of the web application in the JavaScript side extremely simply. Okay, so that was a huge amount of information in a short period of time, but I hope it elucidates a little bit about how you can build permanent decentralized web applications on Arweave and how Arweave functions as a permanent ledger of history. If you'd like to find out more, you can check out rwiki.wiki, which itself, of course, is a Permaweb application stored on the Arweave network. Thank you so much for your time.